All right, so let's begin today. We want to look at decision analysis. Decision analysis. I have already indicated that the leftover for the normal distribution under the probability, I've sent you 2 videos for you to watch them yourself. Please do. It will be a glory to you. What we want to do now is to look at decision analysis. Decision analysis. What is that? What is decision analysis? Well, we all decide every day. And before we normally decide, we need information. People make decisions about the situations and the alternatives they have. Some of them are subjective and intrinsic. For example, you might want to decide whether you should marry this year or you should marry next year. You might decide whether to do MBA or to use the money to start a business or to use the money to travel abroad after topping up. Big decision. Big decision. And the thing is that you need criteria that will help you to decide. Decision analysis is a specialized methodology that helps you to identify, model, assess, determine an appropriate course of action given a problem you have at hand. The process, the methodological ambience under which you go about deciding is made up of using multiple tools to break down the problem into manageable, understandable proportions so that you can understand and handle the problem at hand. So that's what we are going to do. You don't just get up and make a decision. Some people make a decision based on their experience. Oh, looking at the way we did the last time, you can do it. No. You must have a very, quantitatively based or a systematic algorithm. Now, in making decisions, you can decide when you have certain things available and when you have certain things unavailable. You can decide under uncertainty, or you can decide under certainty. Certainty is where you are aware, deterministically, you are aware. Everything we've done, linear programming, integer programming, now all of those programming, analytic, AHP, and multi-criteria decisions, nonlinear programming, dynamic, all of these, we are certain. We are certain of what we are going to get, depending on what we do. We are certain that if we produce nothing, or if we put in nothing, we'll get nothing. But decision-making under uncertainty and risks is in such a way that you are not even certain of the data. And so you got to model it not deterministically, but probabilistically. And we are going to do that. So before you can understand decision analysis, you need to know the 3 main elements of a decision analysis. The element number 1 is a decision maker. You got to know the DM. The decision maker is very important. The one making the decision. Element number 2 is the decision alternative. The decision alternative. That is, you don't make one decision, but you pick that decision out of many alternatives. So you got to know all the available decision alternatives. You also need to know the state of nature. The state of nature. Now, what is the state of nature? The state of nature is the environment, the conditions under which you make the decision. So for example, you can make a decision depending on the weather condition. Whether we're in the summer, autumn, spring, or winter, you make a decision based on that. You can make a decision under the condition of whether the economic condition is good or bad or moderate or that. You can make a decision whether there is this government or there is that government. That is the state of nature. The state of nature is something that is not under your control. You can't control it. For example, you can't control the macroeconomic indicators, the GDP, the exchange rate, the interest rate. But you got to go start a business anyway. But you don't control the inflation. And so you got to make the decision whether inflation is medium, high, low. These things are known as the state of nature. So remember, write this down. You control the decision alternative, but you don't control the state of nature. Write it down. Write it down. And once you're done writing that down, you just type Y. I want to be sure that you are following me. I want to be sure of that. So write it down and let me know. Let me see those. Write it down. Because I'm going to ask one of you to tell me what you wrote. Write it down. Write it down. Write it down. For Sina, what did you write? Or you didn't write anything. And you raised your hand. Nia J, what did you write?
So you control decision alternatives, but you can't control the state of nature.
Perfect. You are the true person who wrote the yes, not the others. So let's start with this. And the final thing about decision analysis is known as the payoff. The payoffs. What is the outcome? What is the result? What is the result? Whether it's positive or negative, the payoff is the thing, the last thing, the last element, the last of the Mohicans in decision analysis. The payoffs is normally in the form of a matrix, a box. That will tell you if you go this pathway, this is what you get. If you go that pathway, this is what you get, given this one, and all of that. I think all of this talk will not make sense until you have a practical example. But what are the criteria? What are the specific strategies, techniques to arriving at the correct decision? Well, these are the criteria. The first one is known as the maximax approach. It is an approach that is used to determine whether to go for a particular decision or not. The maximax approach is also known as the optimistic criterion. You have the maximin approach, which is the pessimistic criterion. You have the minimax and the minimax regret. The minimax regret approach is known as the opportunistic approach. So remember, the bold ones are optimistic, pessimistic, opportunistic. You have the average and equal likelihood approach. We will not look at those. So ladies and gentlemen, let's begin and look at these approaches using practical examples. It is very, very simple. In fact, these three that I've mentioned are these are all decisions that are made when you do not have probabilities. Watch it. You see, the state of nature. We said that you can't control it. But what is the probability that the state of nature will occur? What is the probability that the moment we enter next year with the new government or the old government, what is the probability that the economy will bounce downwards or will bounce back? The probability of it happening, you don't have it. So there are no assigned probabilities to the state of nature. But then you look at the situation where the state of nature have assigned probability. That is, you are sure that this state of nature, there is a 60% chance that the state of nature is going to be like this. There's a 70% chance that the whole of this month there will be snow. We are going to look at these three approaches. These three approaches that you are seeing here, maximax, maximin, minimax regret, none of them has the probability of the state of nature. Any question? Good. Now let's start. Let's start with the first one by looking at a preamble. The preamble will set the ball rolling. Please have your pen and paper, be ready to draw the box as we begin. Kofi Oyo wants to invest among an apartment building. Apartment building is the first decision alternative. We call it D1. Kofi Oyo wants to invest in office building. D2. Kofi Oyo wants to invest in a warehouse. D3. The state of nature that will determine how much profit Kofi will make are good economic condition, which we call S1 for the state of nature, or poor economic condition, which we call S2. Remember, the D1, D2, D3 can go all the way to D100. The S1, S2, S3 can go all the way to S100. The payoffs or the profits based on each one, given each state of nature, are going to be shown down here. So you are the analyst. You have economic condition that is good, bad. As you can see, the arrow is pointing down, meaning the economic condition is bad. The arrow is pointing up here, meaning that the economic condition is good. Should you invest in apartment, or you should invest in office building, or you should invest in warehouse? This is advice you got to give to Kofi Oyo. And these are the state of nature. Now, in order to simplify things, I'm going to remove the 1,000 that is following each number so that it becomes easier dealing with the state of nature. Let's begin, ladies and gentlemen, to look at the first scenario. The first question you have in your hand is the following, which I think I need a very wide space to do this. Whichever space I use. So let's use this one, because this one has got all the things in cities already. So we are going to determine, so the question is, determine the best decision under the maximax approach. That's a question, write it down. Determine the best decision under the maximax approach. Now, under the maximax approach, the way you make the decision is very simple. The maximax approach says that for each decision alternative, okay, that is for each D1. So if we were to be representing this, this would be D1, this would be D2, and that would be D3. And this will be S1, and this will be S2, the state of nature. Sometimes you even get a questions like this. For each decision alternative, because you are maximus, remember the maximus is an optimistic person. That person is optimistic about the future. So looking at the good economic condition and the poor economic condition, if the person were to select apartment building, will he go for the one that gives the 50 or the one that gives the 30? Quickly, you can raise your hand and tell me. Optimistic person. Victor.
You go for the one that gives the 50.
Very good. So here, under the section called, decision choice, that person would choose the 50 here. Now, what about the office building? Which payoff is he going to go for? For the office building. Daniel.
The one that gives the 100 cedis.
100. And how about a warehouse? Can be, okay? Can be. That's the only way because what we are doing is easy now. So you got to build your brain towards where the thing is hard. Dinah.
30.
So you have 30. Now, this person now will select the best of the best. So write it in the note. Maximax is the optimistic approach, and it is the best of the best. So the person will select the best of the best, and that is which number here, which payoff here. Therefore, which decision alternative will this person go for? Among these three alternatives, the person will select which one. Which one is he going to invest or build? Yes, Sandra.
So please, the office building, because that has 100 cedis, which is the highest among the three.
Excellent. So you will now say that, therefore, the best decision is to build the office because it gives the highest payoff. Now remember here, the payoffs, the higher the better. This is not cost. This is profit here. This is benefit. Now, if they are cost or they are this benefit, then you got to select the lowest. So the best will be the lowest. Keep that in mind. There's never been a question on that, only once. And people failed but all. All right. So you will say that the best decision is D1. Then you put your 100 there. Now, the next is the maximin. Maximin, not maximus. So remember, the max was this one, the first one. Yes, Sandra.
Please, you said the best is D1, but D2 is the 100 cedis. I don't know.
Exactly. I was waiting to see whether someone is here. And you see, sometimes you got to be here because some people are just taking things as they are. And once they take things as they are, that's what they lose. So the best decision is truly D2, and that is office building. So you got to have a fullest understanding of what you are running. Please remember the max at the end, not the max at the beginning. That is the best of the best. The next one is maximin. Maximin is the max at the min at the end and not the max in the front. So maximin is the best of the West. Write it down. It is a pessimistic. Now, who is a pessimistic person? Who is a pessimistic person? Yeah, comfort.
Simply somebody who looks at the bad side of things.
Good. So for such a person, let me see whether you guys are smart. Great. No. So for such a person, the person will look at the first decision. Which number will the person select? For apartment building, which number will the person select? We are looking at the maximum approach. Comfort.
Say please 30 cedis.
Select 30. And then for the office building, which one will the person select? Be careful. Dinah.
Negative 40.
Negative 40. And then the warehouse will be 30. Now the person, sorry, the warehouse is 10. The person will have to select which one has the best decision. Who can raise their hand and tell me? The person will select which one has the best decision. You see, Rabina, it's good that you have put your wrong answer down and you have gotten the wrong answer so that you can get the right answer. Charles.
Negative 40.
The person will never select negative 40 as the best decision. Never. Prince.
The person was,
Prince, come again.
well, the person will select 30 because 30 is the best of the West.
That's it. The person will select the best of the West. You see, you didn't write the word best of the West that I said. That's why. So that person is going to select the best of the West. And that best of the West is 30. So using the maximax approach, you build office. Using the maximin approach, you build apartment. Take note of, as an analyst, you got to have all of these approaches. Then you are going to select which one is appropriate. We are done with the first two approaches. Let's go to the third one. The third approach is known as the minimax regret approach. The minimax regret approach. Now, let me ask you guys. Suppose that under the maximax approach that we did, this person selected the 100, which is office building. And he did that specifically because he was expecting the best of the best. So he decided to do the office building. And then in the maximin approach, he selected the apartment. Now imagine when the person selected apartment, the person later realized that the economic condition was, after all, not poor as he expected, but rather the economic condition was good. How would the person feel?
Regret.
If I had muted you, would you have shouted the answer into them? You would have raised your hand and still commented. I want some bit of decorum. Yeah, Prince.
Yes. The person is going to regret.
That is why we have the name as the minimax regret approach. So what does that word tell you if the person should feel regret? By the way, let's calculate his regret. What would be his regret? The regret is actually defined by R-I-J. The person will feel regret. But in this very example, how much would the regret be? Who can guess? The amount of regret would be the amount he would have gained if he had actually done the opposite and the situation has gone his way. So how much regret would that be? Victor?
That would be 70 cities.
How did you get that?
So the difference between 100 minus 30 cities is 70.
Excellent. That is what would have been the person's situation. And so what we need to do now is to look at each of these choices, these payoffs, and determine which payoffs gave us the least regret. Because remember, regret is not good. So you want to have the least. That's what it's called, minimax regret. So first, you are going to find the maximum of all the regrets and take the minimum of those maximum regrets. And that will become the final answer. So let's start to calculate the regret. Now, how do you calculate the regret? Before you can calculate the regret, and by the way, you're going to calculate the regret for each payoff. So this payoff will have a regret, this 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 will have a regret. You're going to calculate regret for all of them. But before you do that, there are some few things you need to know when it comes to regret. First of all, you need to find VJ star. The VJ star is looking at the J means column. I is always row. J is always column. So you look at each state of nature and you calculate, you find the highest payoff. In this case, because you're looking for the each, we are dealing with maximization. So you calculate Vj star, okay? And how do you get that? So there are how many columns here? There are 2 columns. So we are going to look for the V1 star. We are going to use all this to find the regretto. V1 star, and you're also going to find V2 star. So guys, what is the value for V1 star? Who can tell us? V1 star, the highest value in column 1. V2 star is the highest value in column 2. Yeah, Dana.
100 is the highest value in column 1.
Mm-hmm.
And then 30, sorry, is the highest volume in column 2.
Good. This is what you are going to use to calculate the regret for each payoff. So what do I mean? Regret is given by the absolute value of Vj star minus Vij. Write it down. After you've written it down, 10 of you should just indicate that for me. The thing is that I always want participation. Who has written the formula? Vrj or Vij equals to Vj star minus Vij. I need one person who has done that. Write it down in the chat. So you're going to find the regret for each. So let's go to this first one here. Who can tell me the value for the regret here? You remember when I started, I told you that it's your participation that invigorates. If there is none, I parachute. I'm very, very particular about that. And there are 2 ways of participating. Participating by raising your hand, participating by chatting in the page. Yes, Daniel.
I think it's 50.
It's 50. And you can see the answers others are written, right? They are writing so many other answers.
Yeah.
Okay, which is very wrong. Okay, they are writing very, very wrong answers. Okay, that's why. That is the reason why. That you have to talk. You have to communicate. You have to raise your hand. Okay, so this first one is going to give you a value of 50. Let's go to the second one down here. What would that value be for office building? Remember, we are doing for the first column. What would that value be for the office building? Yes, Dana.
So I think it's 0.
It is 0. So this one is going to be 0. Then the warehouse, what would that be? When you come to know what we are doing, you see how easy it is. But when you don't come to know what we are doing, you think that is difficult. Yes, Amino. Daniel.
70.
70. So the third one is going to be 70. Good. Now let's go to the poor economic condition. The first regret for apartment building will be what? Comfort.
There's 0.
0. By the way, there will always be 0 in one of your answers. The second one will be what? Be careful there. The second one will be what? Comfort.
The minus 10.
No. The second one will be what?
Minus.
It's interesting. One of the persons who said, I don't understand and I'm confused, is now writing the question. It's Margaret.
70.
70. Good. And then the last one.
20.
20.
Okay. So these are your regrets. Now, you will now look at each regret for each decision alternative. Remember, you have the decision alternative for each one. Okay. And then you're going to look at each decision alternative and calculate for each alternative, you select the maximum regret. So this next heading should be like maximum regrets. That's what you're going to put there. So for apartment, what is the value? 50. For office building, 70. For warehouse, 70. This is where you go down the lane of the lane of decision alternative, because you are picking the maximum for each decision. Now, out of these maximum, you are going to select the minimum. And so the next column will be the minimax regret. That's the name gives to it. The minimax regret is the lowest of the regret. And therefore, on the basis of this minimax regret approach, this opportunistic approach, which decision should Kofi Waye go for? Which one should he buy? Which one should he buy? Yes, Dana.
Apartment building.
Apartment building. That's it, because it gives you the lowest of the regret. So the most important thing is calculating your regret. And to calculate your regret, you got to know for each column the highest value. Then you subtract that highest value from every other value in that column. So the first one that gave you the 50 is 100 minus 50. The next one is 100 minus 100. The next one is 100 minus 30. And here, for the poor economic condition, the bigger was 30. So 30 minus 30, 30 minus minus 40, 30 minus 20. And this one gave 70 because 30 minus minus 40 is 70. Now, this person is an opportunistic person because he didn't want to have a regret. What he does is that he thinks as though he has lost. So he actually calculates all the regrets, and they calculate, because we said that he would have regretted. He would have regretted with 70. That's what he said. But now he would have regretted with only what? 50. So instead of going for the office building, instead of going for the, what do you call it? Instead of going for the apartment, okay, or in fact, not even just apartment, any of them, whether it's apartment or anything, any of them, and getting a regret of 70, he now goes for, finally, this apartment, okay, because now he knows that he would not have gotten that regret of 70, he would have gotten the regret of 50. So he actually calculates regret before he makes a decision and knows his opportunity. All of these approaches are employing no probability of the state of nature. Everything is here, by the way. There is no probability toward the state of nature. The regret that we calculated is also all here. Now, no probabilities of the state of nature were assigned. But sometimes you will get someone who will give you the probability of that state of nature, the probability of the economic condition going to become good or bad. You can even hire an expert, an economic forecaster, to tell you the future. So given that assigned, now you have to calculate three things. Guys, pay attention here. This is not simple at this stage. You can now find the expected value for each decision alternative. The expected value for each decision alternative is also called expected value without perfect information. Note the informational point here. Expected value without perfect information. Now, the information you have is information, but it's not perfect. And so, instead of sometimes calling it expected value, which in reality is expected value, sometimes you call it expected value without perfect information. And you can be asked to calculate that. Now, how do you calculate expected value without perfect information? First of all, know that probability is always between 0 and 1 inclusive, and the sum of probability is equal to 1. And so once you are told that the probability of a particular state of nature is this, you will not be given the other one. If there are 10 states of nature, the question can be in such a way that the last 2 will not be given to you. But you'll be told in such a way that the last 2 were shared among themselves, so that you will know that whatever value that was for the last one is also for the last batch one. If there are 3 states of nature, S1, S2, and S3, and the probability for the state of nature S3 is 0.3, and the probability for the state of nature S2 is 0.7, what is that of S1? Yes, it's 0. The state of nature for S1 is 0. So understand, and the reason why you got a 0 is here, you had a 0.3 to the 0.7, subtracted it from 1. So you can always find 1 when the others are given. Now, how do you then calculate the expected value? Expected value for any decision alternative is given as this. So if I want to find, and please write this formula down. If I want to find the expected value for apartment, this is how you write it. You write expected value for apartment as EV into bracket D1, because apartment is the first decision alternative. Then you would take the value for apartment, that is a payoff, and multiply it by the state of nature for apartment. So that means that you should always know the state of nature for apartment before you start. Sorry, the probability of the state of nature for apartment before you start. So let's go to the storyline again and see whether there was a state of nature. It says that Kofi Waye is able to estimate a 60% probability that a good economic condition will prevail. What now is a recommendable best decision using the expected value approach? Get this? Oh, ladies and gentlemen, let me just tell you, if there's ever been any question you can answer in an exam easily, quickly, is this one. So, if the state of nature, so watch this, you were told that poor economic condition. Poor economic condition, was it S1 or S2? Was it S1 or S2? It was S2. Okay. So the probability of S2 is equal to 0.6. So in this case, what to be the probability? This is what you got to calculate first. What is the probability of S1? It's 0.4. So With that, you should be able to calculate the expected value for each decision alternative. So remember that the probability of state of nature 1 is 0.4, and that of 2 is 0.5. Let's go to the data. So this is our data now. So I want you to now calculate for apartment building the expected value for decision alternative 1. Calculate that and let me know. Calculate that from your head and let me know. I hope you know what you're doing. Remember that the economic condition was good at 60%, 0.6. The economic condition was good poor at 40%, 0.4. Is that it? So the first one is going to be the expected value of D1 will be 0.6 multiplying the state of the payoff, which is 50, plus that of 0.4 multiplying the state of nature, which is 30. What will be the value of that? One of you who is watching and hasn't spoken and not working should give us the answer by punching a calculator. Okay. So you get 42 for the first one. What about the second one? Calculate even D2. Careful. So I have 44 for the second one, and then you can give me the last one. 22 for the last one. Very good. So using this expected value approach, which is the best decision to go for? Which is the best decision to go for? It's quite strange in the way these things. Which is the best decision? Which one should we buy? Remember, this is payoff. This is value, expected value, not expected cost or pay. So which one should we buy? Is it apartment, office, or warehouse? Office, very good. So based on the approach, yes, Gideon. Based on the approaches we have gone through, how many has apartment building been selected? How many approaches have selected apartment building? And how many approaches have selected office building? Apartment building has been selected twice. Office building has been selected twice. Have you observed that? Mm-hmm. The maximax selected office. The maximin selected apartment. The minimax regret selected apartment. And now the even, the expected value without perfect information has selected office. So office has won twice, apartment has won twice, warehouse nothing. You see, in such analysis, you got to look for the one that is being selected more using all the approaches one by one. Let's go to the next one. The next approach is actually a beautiful one, and it is known as expected loss. It's a beautiful one. Expected loss. Let me go here and start showing you something. We can calculate the previous one, but I want us to do this first. You remember, okay, let me just mention this to you. You remember we indicated that the expected value approach is also called expected value without perfect information. Now, there is a word known as expected value of perfect information. Expected value of perfect information is expected value without perfect information minus expected value with perfect information. I want you to write it down and think about it first. There is expected value of perfect information. What is that? Well, the expected value of perfect information is the price you are going to pay if you were to go for perfect information to be able to make your decision. The value of the price you are willing to pay to get perfect information is expected value of perfect information. Now, the expected value of perfect information, you don't use it to make a decision. And the same way the expected value with perfect information, you don't also use it to make a decision. You don't use it like, you don't do that. Like the expected value without perfect information, the one we just did. You use that one to decide to select whether D1, D2, or D3. But then the expected value with perfect information, you don't use it. But when you get that value, you subtract it from the without, the highest one that you selected, and that will give you the expected value of perfect information. The question though is, we know the expected value without perfect information. It was 44 actually, and it was for office building. We decided with that, but we don't decide with it. But how do you calculate the expected value with perfect information? Well, it's a very simple formula. The expected value with perfect information is basically expected value with perfect information is basically the sum of the VJ multiplying the probability of the VJ, or the probability of the state of nature J. So you take each state of nature and then the value for that state of nature. Remember the VJ star. The value for that VJ star. The VJ star was the highest value in each column. The highest value in each column. If you can remember, guys, what was the highest value in the good economic condition column? What was the highest value there? Dinah?
100.
100. And what was the probability of state of nature for that good condition? What was the probability for that one?
0.6.
0.6. And what was the highest value for the poor condition?
30.
And then there's probability there?
0.4.
So what you are going to do, what this formula is saying is that you take the highest value, which is 100, multiply it by the 0.6, add it to the highest value, which was 30, multiply it by the 0.4. And when you add them, that will give you the expected value with perfect information. Do that and tell me the answer. Sometimes I wait for some to say it. Yes, comfort.
Sir, 72.
So you have this to be 72. This 72 is the price you are willing to pay for perfect information. So when the exam tells you that find the price you are willing to pay for perfect information, you go and calculate the expected value with perfect information. Anything above that, you won't pay. In the movie called 24, the series, there's a lot of information that was known to others, not known to others. Information is important. People will kill for it. You remember when the information about one Bataji came from Equatorial Guinea, it became a big deal. Information. In government, in the CIA and the MIS, information is a big deal. So you use this one only to calculate. And on the basis of that, you can find the expected value of perfect information. Please note the 72 is not actually the right one. Okay. Actually, the formula is the other way around. Okay. Let me just show you here. The expected value of perfect information. Okay. This expected value of perfect information, it is the one that is subtracted from the expected value without perfect information. So the formula is rather this, take note. The expected value of perfect information is rather the expected value with perfect information minus the expected value without perfect information. The absolute value of that. I think I switched the with and the without, so please take note. So the with is the 72, the without is the 44, I think. And the 2 will give you the 28. The 28 is the expected value of perfect information. The 28 is the price you're willing to pay to get a perfect information. Now, the previous one, the expected value with perfect information, is perfect information. Okay. But then you have not handled the without perfect information from it, because the perfect information may have tainted, imperfect information. And so you want to deal with that by taking the one without perfect information from it before you get the off the perfect information. And these have been calculated here. In fact, you know all of the answers. So let me show you this. So the 28 is a maximum amount to pay to buy information from an economic forecaster to predict the future for perfect information for you. We are left with one last thing. So remember, the expected value of perfect information, you don't use it to decide. But EVPI, you don't use it to decide. But the EV without perfect information, this one is actually sometimes simply called expected value. This one you use it to decide because you do it for each one. And this one, even WPI, you don't use it to decide. You subtract whatever you get here from that, and that will give you the EVPI. We are left with one last thing that we use to decide, and that is known as the expected opportunity loss, EOL. Now, these things are not difficult. The only difficulty is you remembering each one. Okay. Now, let me just remind you of the expected value approach. If you can remember, the expected value approach for each decision alternative is a sum of the decision alternative multiplied by the state of nature, the probability of the state of nature. Okay. So each one. Okay. So if the state of nature are 3, each one will be multiplied, each value, each payoff will be multiplied by that. Remember, that is why you go for the highest, because it's value. Now, the opposite is what we're about to do. The opposite is expected opportunity loss. Expected opportunity loss is also calculated for each decision alternative. But this time, you take the sum of not the value, but the regret. So you're taking each regret multiplied by the probability of the state of nature. And then you sum them for each decision alternative. Now, in case you've forgotten, the regret that we had was in such a way that we had 50, 50, 50, 0 here. And then we had what? Is it 30, negative 70? No. What's it? 30, 70. And then 70, 10. 10. These were the regrets. Is that correct?
So please, it's 50, 0, 70. And 0, 70, 20.
So the last one is 20.
Yes, sir.
And this here is what? 0.
Yes, sir, 0.
Yeah.
So you're going to take each one, multiply by the probability of the state of nature. Remember, the probability of state of nature 1 is 0.6. The probability of state of nature 2 is 0.4. So you're going to take 0.6 times 50 plus 0.4 times 0. That's the first one. 0.6 times 0 plus 0.4 times that. When this time, that's that will give you, for each decision, expected opportunity loss. And because it's a loss, you would want the lowest. Do that and tell me which decision alternative you use. And I want to use that to tell you some conclusion, beautiful conclusion in there. Who is done with the first one? What did you get for the first one? What is expected opportunity loss for apartment? Yeah, Prince.
Prof, the apartment.
All right, thank you, Prince. So the first one, you're going to get this. You're going to get 30. The second one, you're going to get 28. The last one, you're going to get 15. Which one do you go for? Which one do you go for? Which decision? Remember, this is a loss. Prince.
Prof, I go for 28.
Good. You go for the office building, and you can see that that gives you 3 decisions that have selected the office building. Do you realize that this one, this 28, is the same value for the expected value of perfect information? So there's a rule here to know that you're on the track or not. Anytime you're doing this, there's a rule. The rule is that this value is the minimum expected regret loss. So that 28, which was the price you are willing to pay, is also the minimum expected regret. It's also the maximum amount to pay for perfect information. They are always going to be equal. Keep that in mind. They will always be equal. And you will notice that the expected value approach selected office, and the expected opportunity loss approach also selected office. It will also lead to the same conclusion, the two. So that's the point I've indicated. The expected value approach and the expected opportunity criteria will always lead to the same decision. Both approach will use probabilities. Don't forget that. Both approach will use probabilities. It's therefore important that the decision maker is always accurate as possible whenever there is a split of nature. So ladies and gentlemen, this is how you analyze expected value approach. The other ones too, okay, but I want to do this. This is a sort of an exam question years back that you was given. This is 25 marks actually. Sometimes there are sample information that are there. You can look at them on your own. Okay. Sometimes there are Bayesian approach that are there. You can look at them on your own in the book. But this was a question. These questions had very simple answers to make, 25 marks. And this was the situation. This time, you can see that the state of nature has gone up. There are 3. And then the decision alternative has gone up. This time, there are 4. So you can see clearly that this approach It's a wonderful approach. And it doesn't matter what, all you got to do is to go that same steps to compute it. Anytime there is a maximization is because we are dealing with a value. The payoffs are maximized. If the payoffs are rather cost, there will be minimization. It's just the opposite of everything that we've done. That's it. That brings us to the end of the entire Tabudo. If you have a question, please, I'm ready for you.